Okay, well, welcome everyone to this meeting of the virtual IMS user group. Thank you for joining us. I'm Trevor Eddles. I'm CEO of ITech Ed Limited. We're a mainframe consultancy, analysis and technical authoring organisation. And we're responsible for the content on the virtual IMS website and producing the newsletters. And just a reminder, the website can be found at iteched.com/virtual IMS. And we also look after the virtual CICS user group as well. Okay, let me run through the agenda for this meeting. As usual, most of the meeting will be taken up with a presentation. And today our guest presenter is Dusty Rivers, who's Director of Z Systems Software, IMS and CICS at GT Software. And his talk is called IMS Can't Do That, or Can It? And a copy of the slides from this presentation should be on the website later today. And by the way, if you've missed any of our previous meetings, you can download copies of the presentations from our website and you can listen again to them. There's a link on our resources page. Following Dusty's presentation and any questions you have for him, we'll move on to the latest IMS news and IMS related articles, blogs, etc. Feedback request is there to remind me to ask you for your feedback about this virtual meeting, and then I'll give you the dates and times for the next couple of virtual meetings. So that's the plan for this meeting. I'm anticipating that it'll last for about 40-45 minutes, something like that. Anyway, as I just said, today's presentation is from Dusty Rivers. Dusty has an extensive 40-year background in global mainframe systems integration, and he's been recognised as an IBM champion for information management for 10 years in a row for his leadership and contribution to the information management community. And this year, he became a lifetime IBM champion for Z. So that's pretty good. His expertise focuses on enabling global organizations to extend the use of their mainframe systems into the world of web services, clouds, and all distributed systems. An engaging speaker, Dusty travels the US presenting on various topics in leveraging IMS for modern technologies. So, Dusty, I'd like to thank you very much for being with us today. And what I'd like to do now is pass control of the meeting over to you. So thank you, Dusty. Stop sharing. And let's make you presenter.
Well, thank you, Trevor. Can you see my screen okay?
Yes, yes.
Okay. So when Trevor asked me about presenting, as he mentioned, I've been working in IMS for a long time. So one of the things that I've heard, and I'll go to the next slide, is I've been working in IMS for over 43 years. And I say over 43 years because June of this year was my 43rd anniversary working in IMS. And for those of you who know Steve Nathan and some of the other IMSers, it's kind of a contest now to see who is going to be the last man standing. And there's a lot more than me that has more experience. But I've been working with IMS systems for over 43 years in various capacities, as a DBA, as a system programmer, as an integrator. And so I've worked globally with a lot of the global IMS customers, both on integration, modernization, and looking at ways that, you know, IMS can fit in the picture. And I say fit in the picture because I keep hearing, oh, IMS can't do that, or the mainframe can't do that, or you can't use IMS for that. So I hope I'm going to give you some ammo for all of the IMS people who are on the phone today when in your shops. And when you hear this, you can basically go back and say, yeah, they can. And so one of the things as I was looking back, and I had to do an article recently, I had to look back, is I've actually been working, of those 43 years, in the last 25 years, I've worked on mainframe integration, that being including the IMS mainframe systems and CICS, but focus today on IMS, on including IMS in the newer systems. I mean, initially it was way back in the days of DCE, then it was using Corba technology or the object request broker, then it was into XML, then it was into SOAP and into RESTful APIs. The idea is some of those systems that we were working with have been around for ages and decades, and they work just fine in the newer technologies. So when I some of the examples I'm going to give you are actually really examples, and that way you can kind of tell this is what's going on. So one of the things, as Trevor mentioned, it was an extreme honor for me this year to be named Lifetime Champion for Z, and that's after years of working as an IBM champion in IMS, in analytics, and that I consider that an honor. And so I wanted to put it up there. So first, let's go with this statement. I've heard the naysayers. I have heard so many people in so many countries and so many companies say, yeah, we need to move all of our systems off the mainframe. But, Trevor made a very good point at the beginning when we were chatting, is you hear people talking about the mainframe and you hear people talking about IMS, but no one talks about the car. I mean, the car has been around for hundreds of years. It doesn't look like it did before. It's still a car, though. There's still telephones. They look a lot different. And we were actually talking about looking at videos and looking at movies. And the old movies, if someone saw a wreck, they basically got out of their car, they ran in someone's door, and they said, "Can I use your telephone?" So IMS has been around. IMS has been around for over 50 years. It's still there. It's still viable, and it's morphing day by day. So I'm going to go through a couple of examples. And so I've heard the naysayers, and this is kind of my motto: try, fail, succeed. And there's an arrow missing from this that I always leave out. Is you try a lot, you fail a lot, and then eventually you succeed. But sometimes even after you succeed, you have to go back and try something new because you want to be constantly changing and constantly adapting. So what I'm going to do first is talk about this statement. IMS can't be part of a large distributed system because it won't scale. And we all on the phone know that that is totally false. It can be, but the visions of most people who view mainframes and IMS systems as old, sluggish dinosaurs, they really don't understand. So what I did is I actually stole this slide. I'll go ahead and say I stole this slide from Skyla and Kyle Charlet. This is a slide, most people today are full of, they're familiar with Twitter, they're familiar with Facebook or YouTube. So if you took a snapshot and said, what happens in a second worldwide? If you look at the number of tweets, and these are probably available higher now, but in 1 second, YouTube has 71,000 views. In 1 second worldwide, IMS runs 3 million transactions. So if you think about that's a pretty good performance. IMS can run in a large distributed environment, and it does. Most companies today, their backbone systems, and I'm not going to steal any of their thunder, but if you listen to Skyla and Kyle's presentation, they talk about if you've ever traveled, if you've ever charged anything, if you've ever flown, if you've ever if you've ever gone to an ATM, probably it's over 90% you went through an IMS system somewhere. So let's go into this. And again, the part I'm going to go through now is could be a couple of hour presentation, but I'm going to skinny it down back to can't be a part of a large system. So what I want to talk about here is a performance study that we did for a large customer. And if you think about it, on the left are all the new devices, the tablets, the mobile phones, laptops. I'm leaving out the wired devices. And all the way over to the right, in the bottom right-hand corner that I circled is a transaction. And that transaction could be something as simple as get policy number, get employee number, get account, get balance, and it's an IMS. And so that feature functionality, business function needs to be exposed to a new application. And you see, for those of you who are fans of The Wizard of Oz, that is the scene from The Wizard of Oz. Pay no attention to the man behind the curtain, because most people assume, hey, I've got a mobile device. I need credit information. How do I get it? Oh, I got a number back. It's running slow. So what I wanted to do is go through a performance study. When you say IMS can't be a part of this, I want to break it apart. So first thing inside that box is the network. Obviously, those devices have to connect to a network somewhere. Probably in your architecture, there's an application server. there's a traffic manager, and these can be physical traffic managers like an F5, or it could be a software traffic manager. And then you have an API server. In this case, I'm using this one. And another traffic manager that's managing connectivity to the mainframe. And while we're talking about mainframe, let's throw in TCP/IP and IMS Connect. So if you look at the left side to the right side, I mean, what can go wrong in this picture? And why are we worried about IMS being the bottleneck when you look at all these other pieces? So what we did is we were doing a performance study for a large customer. It was an IMS customer, it was an airline. And we looked at this and they said, well, things are running slower. And where do you think the blame went 100%? Oh, IMS is running too slow. And we were like, no, look at all the points of failure. And so what we did is we said, okay, let's start looking at this stuff. So the first thing we looked at, obviously, because they said they were blaming IMS, we wanted to make sure when the customers on the left had a request that we had an adequate number of message processing regions. We needed to make sure we had enough worker regions to satisfy the traffic coming in, which we did. Also, we needed to make sure that the transactions that were being exposed had sufficient parallelism, parallel limit counts, process, the number of counts that were out there, making sure that even though we did have the regions, the transactions could be scheduled parallel regions, they could schedule across regions. And then one of the things we had to be very careful with is callouts, is if a program inside of IMS actually wants to call out. And so if you take everything on the left and not worry about it, if IMS is calling out on the right side, that MP region may be blocked. It may be blocked until it comes back. So you want to make sure, even though you have enough MP regions, that the MP region you're trying to schedule into is not blocked by a callout request. And of course, you want to make sure you do your due diligence on your database tuning and make sure that you're not bringing back tons of rows or tons of segments back to be delivered. One other thing is I'll make I guess you would say, an advertisement here. If you're using IMS Connect, you need to be using IMS Connect extensions. It gives you a very good picture. We looked at IMS Connect, we looked at the traffic, we looked at the number of data stores, how it was being managed. This, you have to look at this. I mean, if you think about it, so far I haven't gotten off the mainframe yet, and we're looking at all the possible things we can store there. If your TCP/IP process, you need to look at the number of TCP/IP buffers. Do you have sufficient buffering? Do you have buffers waiting? Do you have traffic waiting? And also to manage your governance and some of your control and flow, if it's a great idea to go ahead and configure and use ATTLS. Then when you get into, if you take a step back, looking at the network routers themselves, many customers, including this one, had the idea of global traffic managers, which basically control local traffic managers. And you have to look at, okay, how are those scheduled? How is the traffic passed off? Including the fact that maybe you have a sticky session, meaning that maybe between that traffic manager and the application, you leave it open and you don't go down after each conversation. That was problem number one, is they were basically setting up and tearing down connections every single time. Then look at the network. I mean, how is your network configured? And when you say network, you have to take into consideration all pieces of the network. Your physical wired network, your Wi-Fi. How is your Wi-Fi configured? Obviously, this was an airline, so Wi-Fi at the airport, Wi-Fi at the terminal, Wi-Fi in the office, and then 4G and 5G standards, not to mention the network latency. If the distance, in other words, if that mainframe all the way to the right, which we left a few minutes ago, is in one city and you're in another one, how many hops are in the network do you have to look at? Also, if you're running a distributed server, there's some Linux or some distributed tuning. There's also some application server tuning. Then, heaven forbid, we had to go back to the application guys and say, okay, have you tuned your apps? In other words, if you have a mobile app and you're pulling back 1,000 rows and you're trying to drop that into a scrollable window, is that really what you want to do? And is that a really good response time? So we had to actually involve the application people. And then in their case, they were using an application server from IBM called IAB. So with all of these points and arrows, you see everybody's pointing in different directions. It was a true team effort. And what they found out from this tuning effort, it was not IMS, it was not the mainframe, it was not IMS Connect, and it was not TCP/IP. What they found out is in the network, some of the routing rules were incorrect. Some of the servers in the network were not configured for high availability. And in true form, they were, their statement was, oh, it has to be IMS. IMS can't handle this load. It was another myth disproved that it really wasn't IMS. It was all the stuff that you put between the left and the right. So I kind of wanted to throw that out as a context for when in a company, when you're talking about, oh, it has to be the mainframe, if you really have to look from the left to the right, do a complete, walkthrough of all the pieces and moving parts. So the next thing is, as we all know, when we're talking to IMS, and I throw this up because when we talk about how simplistic or how hard IMS is, basic communication to IMS, regardless of where you're coming from, whether you're coming through MFS, through a mid-mod, is LLZ transcode data. Or if you've got multi-segment, it'll be LLZ transcode data, LLZZ data. That's the way data is coming into IMS from wherever. Now, the mid-mod is, basically if you're coming from a screen, basically maps the input and the output message format. And the diff-doff really just makes it look pretty on the screen, so you really don't worry about that. But at the end of the day is, okay, how is the program going to be invoked or used? And, that's PL1, that's COBOL, that's an assembler DSEC, that's whatever you do in Java, a Java class. You really have to be concerned, okay, how is the data mapped? But at the end of the day, the data going to IMS is going to be in the format LLZ transcode data. So I wanted to talk about a few things, and I'm going to run through a few examples. If you think about most of our applications, they were designed to interact with 3270 terminals, meaning there was an end user sitting there. The end user knew to go to screen 1, select something off the master menu, drill down for a function. So you really have to start thinking of functionalizing IMS down into, okay, what I really want to do is get an account, get a policy number, get a insurance view. Also, there's a big move. Okay, we're working with customers that say, hey, we're going to go change the IMS legacy code to work better as an API. Basically, letting the program that's been running for 20 years, we're going to change it so we can pass it an indicator just to say it's being called for an API. And the reason I have changing in red is that's always dangerous. Anytime you change something that's working, you introduce complexities that you really don't want to deal with. Also, one of the things, IMS is built for speed. One of the keywords that I use when I speak at Share a lot is key bounce time. And what that used to mean is back in the day is when I worked for a telco, is the service representative, when they went in, one of their PF keys mapped to get your account information, and the speed that message had to come back to that user was when they pressed the PF key, by the time the key bounced back up, that response better be there. So they basically didn't care about milliseconds, nanoseconds, microseconds. It was key bounce. Oh, when the key bounces up, I better have a response. And if you map your new systems based on function keys, sometimes you have way too many services that can become very complex. Also, if you make the applications a little bit more intelligent, it'll drive more functionality. And this is for those of you who know me, a friend of mine who's a salesman, his basic statement is mainframe apps are like a box of chocolates. It's hard to see what's inside until you bite into them. And that's true, because a lot of the times you think, oh, this IMS application, oh, it just brings back a customer number. But what you don't realize is that IMS transaction in the background, it actually ran message switch to transaction 2, which message switched to transaction 3, which actually returned an answer. And you really didn't know all that happened until you drilled into it. So a couple of things I'm going to talk about, since I've talked about integration. I've heard IMS cannot be included in an API world or an API economy. You can't do regular transactions. Conversational transactions, you might as well forget. 3270 MFS transactions, yeah, we don't even want to talk about that. Complex transactions, including things like I've got one request coming in and I may have 5 or 6 different formats coming back. I'm not even going to deal with that. Also, IMS needs to communicate with other systems, either via call out or through some other mechanism. And then now the big keyword is DevOps. And, IMS participating in DevOps, right. Also running the container, and I'll explain that when I get to it. And case studies. I've actually got at the end of this 3 case studies that we can talk about of real companies. So all the examples I'm going to talk about were taken from real live customers, production examples. The names have been changed to protect the innocent and protect me from somebody saying, hey, you used my name. So the first thing, let's talk about regular transactions. And I'll be using a modeling tool here. The idea is, okay, here's a visual representation. All I really want to do is take the IVT transaction, and I want to expose it as a RESTful API. It has inputs, it has outputs. You can do that real quick. There's a lot of tools that do that. And for someone saying you can't expose IMS as a RESTful API or a SOAP API, you can do that very easily with modern tools. And so when someone says you can't do that, it's too hard, you can say, yeah, you can, and there's tons of information on how to do that. So I can kind of say regular transactions can be exposed as RESTful APIs. Conversations. Now, when you talk about conversations, sometimes there's a little bit of confusion, but this is how I define a conversation. Conversations were designed where a user sits down at a terminal, they enter something else, they enter something else, and eventually they log off. Well, that was modeled the conversation. There was a scratchpad area that was created, and that scratchpad area, our SPA, was passed from transaction to transaction with data that was needed for the second one to run. So you need to encapsulate or include the entire transaction in an API. By that, I mean the transaction has to do something like start a transaction, continue until you're done and loop through, and then stop. Because you want to make sure you stop, because you don't want to, and terminate and clean up, because you don't want to leave a lot of conversation threads laying around out there in the conversation pool. But you have to encapsulate the entire conversation as an API, which means in that middle step where continue, you can't stop in the middle there and go back and ask the user, hey, did you really mean to put a 2 here or a 1? Because, the whole nature of APIs, whether they're REST or SOAP, is stateless. So you have to start thinking functionally, how is this conversation going to be invoked? And then MFS. So one of the things that we've gotten into a lot lately is there's a lot of customers who basically think, okay, this transaction was initially designed to be run from an MFS map from a screen. Not a problem. As I mentioned earlier, the mids and mods, you convert those to copybooks, and then you just have inputs and outputs, but you have to worry about things like offsets, where's the transaction. But also one of the things you have to be aware of is those MFS maps may have been doing functionally some of the things that you didn't know about. Things like maybe it was zero filling numeric fields, or maybe it was blank filling alphanumeric fields. And maybe it was checking for numbers, making sure you're putting a numeric in a field. And also hidden data. By hidden data, and this is the thing that bites most often, is my previous example was conversational transactions. Many people didn't want to do conversational. So what they would do is in the MFS map, they would have a hidden field that they would stuff data in. So the transaction would run, it would stuff data in MFS map, pass it back to the user. They would enter some other stuff, and it passed that hidden field back. Well, if you didn't know about that hidden field and you try to API enable that transaction, it's, you're going to have issues. So you need to know that. Also, complex transactions. This is actually my favorite, because this is an example of one transaction running, and it has the capability, as I mentioned earlier, to return 8 different outputs. So maybe your copybook input is one thing, and then based on what it does, you get a different format, in this case, 7 or 8 different formats coming back. And this could be as simple as the transaction message switch to transaction 2, which returned a response, or maybe it message switched to transaction 2, which went to 3, and it returned a different response. Or out here on the left side over here where my mouse is, maybe you're returning a multi-segment output and you need to page through the response to get back. So when you start looking at that, we had customers say, oh, my application is too complex. It returns way too much data. It can't be included in my application. Also, communicate with other systems. By this, I meant when you create APIs and IMS is included, yeah, it's kind of tough to include other stuff in there. And maybe there's stuff that you want to include, but it's not that easy. So what I did is I was asked by one of our customers to create an application or an API. And this, look, you probably can't read this now, so let me make it a little bigger. So what they wanted to do is they execute an IMS transaction. And then based on the response, they can either call another IMS transaction, they can call a CICS transaction, they can call an external SOAP API or an external REST API, and they can also call maybe an external API that's hosted by ZOS Connect. So the idea is IMS can participate in a cross-discipline service based on multiple platforms. And, it's kind of silly because as I showed you in the performance study, IMS is 90-something% of the time not the issue when you have those type of problems. So, this is a real example of a customer wanting to call multiple things that include IMS as kind of the driver of what to call. So participate in DevOps. Now, I mentioned earlier that when I started in IMS, when we went from test to QA to production, most of your concerns were the systems people did the stage one, the applications people did the program, and maybe the DBAs helped them with the PSBs and the DBDs and the ACBs, and to go from, and the database changes. So to go from test to production, you had a couple of groups. Now that's a little different. By that, I mean, what about all this? So as we're working with customers, in fact, one of the customers, they have IMS participating in a DevOps pipeline. So to go from test to production or test to QA, you have all the IMS components, you have any API components, you have maybe some things stored in GitHub. They're using Jenkins automation in coordination with Urban Code. They're using different languages. They're using .NET, they're using Java, they're using Node.js and COBOL. They have changes to Linux, they have changes to JBoss Tomcat, and they're using distributed tracing. Also, they're looking, they're using OpenShift containers, so they have that to look at. So now it kind of clouds the issue of how does IMS participate? It participates very well. So when people have told me, IMS cannot participate in a DevOps. I can give you an example of several customers that are doing that today. So it's just simply not true. You can say, yep, IMS can do that. Running a container. And actually, I stole this one last week at Share, or the week before. Skyla and Kyle mentioned that, IBM has got a statement of direction that IMS itself is going to run in a container shortly. I don't know when that is, but there's also going to be able to orchestrate it through Kubernetes for those containers on ZOS. This is something that's going to be coming. There's also going to be OpenShift on Z. So the idea is, even though you're going to say IMS is over 50 years, the fact that they're going to be taking IMS and applications and databases, putting them in containers, and being able to run them in a new container runtime is pretty exciting, because when you think about that, then you basically inherit all the positive features of that container environment. So case studies, this is where we wanted to get to. So I call this IMS Can use cases. These are 3 companies worldwide that are all, and I picked 3, that are all IMS customers. The first one is a French bank. And I will tell you, and kudos to the person in the next 3 use cases who can find the error in my slide. I was doing this at one of the IBM Champions call, and one of the guys on the call said, "Hey, you got an error on that slide." And I said, I didn't even know that. So someone can point it out, let me know, and I'll send you a prize. Large French bank. So the French government mandated the idea of instant payments, the idea to do a the idea that they wanted to post payments immediately. So if bank one wanted to send money to bank two, what they used to do is bank one would initiate a transaction with an intermediary bank. That intermediate bank would hold it for a day and then transfer the money. But due to anti-money laundering and know your customer concerns, the French government dictated that you have to do instant payments and you have to do it now. And if you don't do it, you're going to be subject to fines. So this French bank said, hey, we want to do this. And oh, by the way, our system that we post payments today is an IMS PL1 online system. So when they do that, they execute a transaction. Today, their solution was they wanted to generate a way for that installed IMS PL1 transaction to do that, thinking it was talking to another application in PL1. They called out to FIS's clear to pay solution from a core banking, it says COBOL, but it's also COBOL in PL1. But the idea is they did this to satisfy government regulations. They're still using IMS, they're still using their native language, but now they're participating in the instant payment solution. The impressive thing about this is when they talk about the mainframe is slow, IMS can't do anything fast. You can't do anything with IMS fast. They actually went from proof of concept to production in less than 2 months, which is pretty impressive when you think about, the regulations, the security. And again, I'm not going to dive into it here, but if you think about the pure security concerns of one bank transferring money to another institution, doing it live, doing it real time, and satisfying the auditors. In the US, it would take us 2 months just to satisfy the auditors, but they were able to do it in 2 months. A large airline, which is actually presented several times at Share and at Think on what they did, is we had 2 airlines that merged. And as a regulatory requirement, they needed to provide one management control system for parts management, repair, parts inventory, and things like that. And they had multiple aircraft maintenance systems. And they had to do this in a seamless manner to satisfy the merger, and they had to do it quickly. So what they wanted to do was generate APIs. They decided that their core system was an IMS system that had been around forever. It had been around for decades, and they wanted to API enable that system. And one of my favorite stories that I've shared before is we were exposing one of their transactions as an API, and we ran into the issue of what used to be called null terminator or a hex 3F. And we got one of the programmers to say, where is this used? And they actually went back to a piece of code, and that was put in the code that we were exposing as an API in 2019. That was put in the code in 1978. The comment was in there, so-and-so adding the code for null termination 1978. So the idea is these systems have been around forever, but they provide the backbone of the company, and they want to expose those as APIs. They were able to do this, and they've since expanded it on a multi-year project where they've actually exposed hundreds of IMS transactions and sets of transactions as APIs. And, they depend on this daily, and that system is not going anywhere. And one of the things that they said is, their company could not have rewritten that IMS system to provide this, easily. And that's another thing is, that was the other option is they said, we will just move this IMS system off of the mainframe to a distributed service. And they found out that was cost prohibitive. It would take way too long, and it would be so dangerous to try to replicate that on another platform. And the third one is a large Swiss bank. Their challenge was to implement the ability to verify a new customer. By that, I mean is they had regulatory requirements that they needed to check for anti-money laundering and like terrorist requirements, that if somebody opens an account at any of their branches or any of their banks through any of their web applications, that name and credentials are checked against a known status. In other words, I said known criminal, but it could be known money launderer, known whatever. And then wherever you are, and I saw this demonstrated from a web app, I saw it demonstrated from a bank teller, and I also saw it demonstrated somewhere else, that on the web app, it comes back with a little pop-up and says, account okay. On the bank teller, it actually shows up as a colored line that says green is okay, yellow you need to check, red, click the F key to check the next screen. But the idea is they had to have a uniform set of APIs that could be initiated. And again, they were using PL1. Their IMS PL1 system had to be able to call out to a third-party system to be able to do that call. But they wanted to do that in both REST and SOAP. And they didn't want to write any more code. And as I mentioned, they want to do it at the integration layer and on the mainframe. Then what they decided is once they created these APIs, they wanted to reuse those APIs across the business, across the other lines of business, to be able to provide the same functionality to other applications. So they were able to standardize that. They were able to do this. They did it. The IMS systems are intact. The PL1 systems are intact. And so, from their business, they were able to tell their stakeholders, yes, IMS can do this. IMS can participate in anti-money laundering. IMS can participate in Know Your Customer. IMS can participate in real-time credit checks. So all the things that they said IMS can't do, we've been proving for years what IMS can do. So, I'm ending a little early to give you a little time back, but at the end, I want to say IMS can, IMS has, IMS will continue, and all the systems that we deal with. As anyone says, I take it as a personal challenge when somebody says you can't do that with IMS. I will say, yeah, we can. So, Trevor, I will turn it back over to you now, and hopefully I didn't go too fast.
That was brilliant. Thank you very much, Dusty. If anyone's got any questions now, if you'd like to type it into the chat box, and we can ask Dusty while we've got him. Well, Dusty, can you give everyone your email address in case they want to come back to you with anything?
Yes, it was on the front. It's on the first screen, but it's drivers@gtsoftware.com.
Okay,
it's on the first slide.
Yeah, and copies of those slides, like I said, should be on our website later today.
As soon as I mail them to you.
All right. We have a question. Oh yeah, is this recorded? Is this recorded? I missed a lot due to an interruption. Yes, the whole session is recorded, and that will also there'll be a link on our website to that on our YouTube channel, and that'll be again later today. It takes a while for WebEx to give it to me, and then I do a little bit of editing, so it'll be much later. And comment for you, Dusty. What I heard was terrific. Thanks. That was from Karen Tischer.
Well, thank you.
You got any more questions? Any more comments? Okay. Well, in that case, I'll move on. If you do have any questions, you can either send them to Dusty or to me.
So, Trevor, just to let you know, someone did catch my error. So I'll give them a call out because they did. Sylvia and Favreau, I apologize. In the case study that I showed the picture of the large Swiss bank, that picture is actually not of a French bank; it's a German bank, and he caught it.
All right. Oh, well done. Well done. Yeah, Rosemary Galvin's asking, where was it? Can you tell us exactly where it was, apart from being in Germany then? Or?
I think it's actually one of the Deutsche banks.
Ah, right.
I think that's what somebody told me. The person who put that slide together just said, "Oh, this looks like a good French bank," and I'm like, I just took their word for it. So.
Okay, I've got a question from you from Lauren Berntson, and she said, I'm interested in knowing what tooling is available for diagnosing a transaction from start to finish across multiple platforms.
Okay, what we used was a tracing platform called Dynatrace, and Dynatrace actually has agents that run on all. It's not one that's made by my company, but it's called Dynatrace, and it allows you. There's an agent running on each piece all the way across, so you can see what time is being consumed and used on each platform. So that's how we were able to figure out, okay, here's the time spent in the application layer, the transport layer, the UI, the Tomcat, the mainframe. It doesn't extend to the mainframe yet, but there is some stuff that will extend all the way to the mainframe to do that. So it was a tool called Dynatrace.
Okay, brilliant. Gary Oosterhuis has just said that that bank is actually in Frankfurt. So next time you do your presentation, you'll be able to tell people exactly where it is. All right, brilliant. Thank you very much. If anyone else has got a question, then either email me or email Dusty directly. If you email me, I'll obviously pass it straight on to him. So let me change myself back to presenter. And let me just say thanks again then, Dusty. That was brilliant. And because we're a virtual group, please assume that you're now getting a virtual round of applause. Let's just... Right. We haven't got any IMS news. If you know of any IMS news, if you can send it to me, that would be brilliant. Let me go on to articles. And again, there don't seem to have been any articles or blogs for a little while. If they've moved somewhere from their usual place, if you can let me know, that would be good. But a Google search and me searching hasn't found any. So, feedback requests. Yeah, I always like to get feedback from the meeting, so if you do have any comments, please let me know. You can tell us what we've done well, or you can tell us what would be better if. The email for your comments to me is on screen, or you can use the Contact Us page on our website. So moving on to the future, you can see our next meeting is on the 8th of December, and the presentation is called Performance on IMS Part 2. I'm not quite sure why it's Part 2. I know that Part 1 of this is going on at GuideShare Europe, so perhaps that's what they're thinking. And that's James Martin, who's a Senior Solutions Advisor at Rocket Software. He'll be talking for that. And then we move on to next year, 2021. Yes, I wonder how different things will be then. Anyway, we've got Nick Griffin, who's a worldwide IMS specialist at BMC Software, and he's going to be discussing reach the IMS database 4/8 gig line. Now what? So that should be interesting. Yeah, just a reminder that you can keep up to date with what's happening in the world of IMS and on the virtual IMS user group website by following us on Facebook and Twitter and by joining the virtual IMS group on LinkedIn. The URLs are all on screen at the moment, but they're also on the homepage of our website. And remember, everyone likes likes, so if you go to our Facebook page and like it, that would be great. And if you tweet or Instagram or any of those things, then the hashtag to use about this meeting is #virtualims. So that's all for this meeting of the Virtual IMS user group. Can I thank you all for attending? Thanks to Rocket Software, the people who sponsor our user group. And of course, I want to particularly thank Dusty Rivers for today's presentation. Yeah, he's just emailed everyone his, it's just messaged everyone his email address. So that's it. Thank you all very much for joining this meeting. And I look forward to seeing you next time, which is on the 8th of December. So thank you all and goodbye.